Okay, so what we're going to talk about today is we're going to talk about factoring. Previously, what we did with factoring is we had something like 3x to the fourth minus 9x squared plus 6x. You did what with that last night? What were you to do with that? Factor, do what though? Take out the biggest piece. Take out the common. In this case, 3x leaves, what you got here? 1x cubed minus 3x. Do you buy that? Plus 2. Now, it's going to be 2 because you got to take the 3 out of the 6. Turns into 2. Take the x away. And so you get this. This is step number 1. Take out common. Take out common. Now, in this case, I have 2 chunks, and there's nothing I can do with the chunks that are left. What I need to do, though, is I need to look at something more like this. X squared plus 6x plus 5. X, yes, sir.
Are you recording this?
Mm-hmm.
Are you going to put it on?
Mm-hmm. I am. So, in this case, we have x squared plus 6x plus 5. And so what we're going to do is we're going to try to break this up. Well, what we need to figure out was what 2 things actually went together to make this. Well, here's my question. What times what equals x squared? X times x. That is it. Those are the only choices, right? Okay. Alternatively, what makes 5? 5 and 1. Okay. So 5 and 1. Now, every sign in here is what? Positive. So I got x, I got 5, I got 1, and everything's positive, so why don't we just keep positives there? Now, to prove that we got it right, what can I do? Multiply it back together. Now, how do I multiply these? Somebody tell me how to multiply these. Foil. I could foil, or what do you think, Lipa? Okay, you're going to say foil? Now, foil is great. Foil is first, outer, inner, last. Where did you learn that? I don't think you probably learned that in 2nd grade. Okay, same thing basically. Yeah, 2nd grade, 6th grade, totally the same. Okay, yes. That's it. First, outer, inner, last says first times first, x squared. Outer times outer, 1x. Inner times inner, 5x. Last times last, plus 5. What do I do in the middle? Combine. Yes, Mr. O'Brien. Why didn't I do anything with 6x? The answer is right here. Because when I give away the x to the 5 and the x to the 1, what does that make in this middle bit? The 6, it shows up. Now, somebody else said, well, that's the same thing as distribute. So let's do that instead. So here we go. X plus 5. X plus 1. Here we go. If I were distributing this, how would it work? Somebody tell me. Yes. X times x. Well, gee, that looks familiar. Okay. X squared. Then what? X times 1. 1x. Then what? 5 times x. Then 5 times 1. So it literally is the same thing, right? Now, so why do we think distribute versus foil? It makes no difference. These are just ways to remember it. In fact, you want to do the happy face method? Let's do the happy face method. Are you ready? The happy face method is if I have 2 sets of parentheses and I give first times first, outer times outer, inner times inner, last times last, and I have some plus signs, it's a happy face. It makes no difference. It's all the same stuff, right? It literally, see, look, it's his eyes, it's his ears, it's his mouth. Look, let's give him a goatee. There is a goatee. We'll give him a mohawk. There we go. There you go. All right, give him some eyebrows. What's up? Eyebrows. Okay, so there we go. Makes no difference. But it's kind of creepy looking, honestly, at this point. Now, let's go over here. And let's do it this way. Let's go 2x plus 3 And let's go 4x plus 2. And let's put them together. What do we get? 8x squared plus 4x plus 12x plus 6. Everybody good with that? How many parts does this have? 4. So it's a polynomial, isn't it? Now, let's do a little trick. Let's take just those 2 bits and just those 2 bits. What's common to just those 2 bits?
4x.
Oh, thank you. 4 and an x. Let's see if I can write the other hand. Sadly, it's just about as good. Do you agree?
Yeah.
Now, let's go over here. What about those 2 bits? 6. That's way easier. What do you notice is over here and over here? 2x plus 1. So can I take that out? So it's like, what's left if I take this out of here? 4x. What's left over here? 6. And what goes out front? 2x plus 1. Now you say, well, that's different. Well, a little bit different, isn't it? But if I put it back together, would it literally go back to be the same stuff? Yeah, it would, because this is just 2 times x plus 3 times 2x plus 1. And up here, I could also make it 2x plus 3 times 2x plus 1 times 2. All those things are the same. Now, let's talk about factoring. And instead of giving it to you broken up, let's put it together. Let's go x squared plus 7x plus 12. Now, we have a small problem, Mr. Larson, with this one, because I can break the x squared up pretty easy, can't I? I can say x and x, okay? And what can I do with the 12, though? I got x and x. I got 12 and 1, 6 and 2, 3 and 4. Ugh. I got to use all. So, like, I could have to guess any one of those, right? So it could take a while. So let's do it this way. What we're looking for, and this goes back to your question, Mr. O'Brien, how can we do anything with the 6x in the middle? I want to break up the 12 to make the 7. Which one of these guys over here makes 7? 3 and 4. So this is the most reasonable choice, isn't it? So could I say this? X squared and plus 12, but let's break the middle up into 3x plus 4x. Could I do that? What's that? Oh, I forgot a plus sign. Thank you. Could I say 3x plus 4x? Now, let's look at these two. What are those two? What's common? X. So let's take an x out, leaves x plus 3. Do you agree? Let's go over here. Janvrin, what's in common with those two? 4. Okay. So 4 leaves x plus 3. Do you agree? So what can come out of this part and that part? What's x plus 3? Could I do that right here? X plus 3 leaves what in here? X and a plus 4. So it factors it out. Now, we have basically 2 things that we've talked about. We have talked about 2 methods. One is called guess and check. Guess what we do for the guess and check method.
Yes.
We guess and then we check it. That's right. Okay. The other one is the undistribute method. The undistribute method. Now, let's do the same problem, but let's do it 2 different ways. Let's go x squared. And I'm going to go minus 3x minus 4. X squared minus 3x minus 4. We're going to do the same problem. We're going to do it both ways, right? Here we go. First of all, what would make, let's break this up. What do the x's break into? X and x. What do the 4s break into?
1, 4.
1 and 4, 2 and 2. But if I did 1 times 4, or I did 1 plus 4, what would I get? 5. Oh, because this is negative, what has to be true about one of these guys back here? Negative. Do we want to make it negative 1 or negative 4? I don't care. Negative 1, they say. Do you want, well, here it doesn't matter, does it? But could I also do it the other way? Could I do that? So now have I truly listed all the possibilities? O'Brien. Yes, I can. Sorry. Thank you. Oh, like that? How's that? Better. Cool. Now, here's my question. We're looking for what in the middle? Negative 3. Which one of these makes negative 3? Well, here you got 3. This is 0, and this is negative 3. So which ones am I interested in? So I got x squared plus 1x. How do I know it's plus? Because it's positive. Then what? Minus 4x. Then minus 4. Because they multiply to make negative 4, but they add to make negative 3. At this point, Faith, what's common to both of those two? They both have a what? An x in it. So let's take it out, leaving an x here and a 1 there. What is common here? Be careful, folks. Thank you, Spiegel. A negative 4. Now, if I take negative 4 out of negative 4x, what do I get? 1x. And what do I take if I get negative 4 out of negative 4? Be careful. Positive 1. Now, why is it positive 1? That's right. Because if I put it back, it'd have to be negative 4, wouldn't it? What's common to each of these pieces, Braxton? Right here. Okay. Heiser, your thoughts. What's common to both of those guys?
X plus 1.
X plus 1. So x plus 1, x plus 1 leaves x and a minus 4. Now, here's what some folks wonder. They say, wait a minute, where'd the other x plus 1 go? Because how many do you see here, FL? How many x plus 1s do you see? 2, but how many do you see here? 1. Well, where did the other one go? When I distribute it, don't I give one to each piece? Opening it back up. So here's my solution. Now let's go over here to the guess and check method. Guess and check method says, what do I do with the x's? X and x. Over here, what do I do with the 4? 2 and 2. 1 and 4. So here we go. Parentheses, parentheses. So step number 1 was take out common. Was there anything in common? Well, that's where we're going. First step was take out common. Was there anything common to take out? Well, there's no x over here, so we can't. So the step number 2 was make yourself some parentheses. Step number 3, what do you put in those parentheses? Close. X's, because that's the ones that are guaranteed, right? Now, what do I put next? Which one do you want to go? 2 and 2 or 4 and 1? Okay, he wants to guess 2 and 2, right? If he guesses 2 and 2, then what kind of signs do you want to go with? Positive and negative, so let's check it. Bar, x squared, bar, negative 2x, bar, plus 2x, bar, negative 4. Uh-oh. Did that work? It did not. So when we guessed, we had to check, but it didn't work. So let's try again. For part B. X, instead of 2's and 2's, what do you want to go with? 1 and 4. Now, here's my other problem. How do I know where the negatives go? Do I know if the negative goes first or second or what? You just guess. That's why it's called guess and check. Which one do you want to guess? Negative 4, he says. All right. And so let's check it. Step 5. Check it out. You got your signs in here. So let's check it out. We get x squared minus 4x plus 1x minus 4. What happens to those two middle bits? x squared minus 3x minus 4. There you go. Okay. And so that did work. Which method is better? Which method is better? Yeah, here's the thing. They're kind of the same, aren't they? Because you're still trying to figure out. This one has a little bit more reason to it, but whichever one works for you is fine. But usually we think about undistribute. So with that, we'll go on to our homework from there.